Hi, now we are discussing the chapter of circles. So here I have drawn one circle and also three lines are there, L1, L2, L3. You can see that L1 is not crossing or not touching the circle, but L2 is another line which touches the circle exactly at one point, and L3 is crossing or intersecting the circle at 2 points. So three lines are there, L1, L2, L3. L3 is known as secant because it crosses 2 points of a circle. L2 is known as tangent because that L2, the line L2 exactly touches the circle at one point. So use the word touches. So L2 is a line that touches the circle exactly at one point. Such a line is known as tangent, and that touching point is named as point of contact. What is that? Point of contact. For L1, there is no special name. For us, we need only L2, the tangent. So for the entire chapter, we are going to discuss the concept of tangent. So tangent means it is a straight line that passes through or touches exactly at one point of a circle. That touching point between that tangent and the circle is known as point of contact. Remember, for grade 11th in physics, in the topic of projectile motion, hopefully you will be doing the same concept, like concept of tangents you will be applying in physics in projectile motion in order to get the direction of that object in projectile motion. I think you will discuss that one in grade 11. So what is a tangent? Tangent is a straight line which touches exactly one point on the circle. That touching point is known as point of contact. L3 is a line which touches 2 points, which is known as secant. Now we are discussing another important point from this chapter. Listen here. Here there is a circle whose center is at O, and through the point A, we have drawn one tangent. So there is a tangent which touches the point of contact A to the circle. I think it's clear for you. The point is nothing but you can see that here I have drawn one radius through the point of contact. Remember, the angle between a tangent and the radius through point of contact will be always is equal to 90 degree. So that concept is very important. I repeat the concept again. What's the point? There is a tangent. That tangent is passing through point of contact A. Through that point of contact A, I have drawn one radius OA, which is denoted by R. I can tell you that the angle between tangent and radius through point of contact will be always is equal to 90 degree. That is an important point in exam point of view. I think it's clear for you. What's the point? Angle between the tangent and the radius through its point of contact will be equal to 90 degree. So remember this point. It will be more clear while we are doing questions based on this topic. Now we are discussing the topic of tangents from an external point. All of you listen here. I'm having a circle. There is an external point, that will be P. So P is an external point to the circle. You can see that from point P, you can construct a tangent PA towards a circle. Also, from the same point P, you can draw another tangent to the circle through the point B. So in simple words, P is an external point. PA and PB are the tangents drawn from point P towards a circle. So we can say that from any external point of a circle, we can construct two tangents towards a circle. I think it's clear for you. And one more thing you have to remember, such two tangents drawn from the external point of a circle are equal in length, which means the length of PA and the length of PB will be equal. So in exam, you can expect a question like this. Prove that the lengths of the tangents drawn from the external point of a circle are equal. You can expect a question like that. So we need to prove that PA, length of PA and PB are equal. So let me explain the proof of that one. You listen here. You can see that I'm going to explain how PA is equal to PB. So A is the point of contact, B is another point of contact. We know that there will be a circle, center O. Let me mark between AO, it's a radius, BO is another radius. As A is the point of contact, listen to me properly. A is the point of contact. PA is a tangent. According to the previous concept, we know that that tangent PA and the radius AO through the point of contact are perpendicular, which is equal to 90 degree. Similarly, this PB and OB are also perpendicular. I can mark that one also as 90 degree. So simply I go angle A is equal to 90 degree, angle B is equal to 90 degree. The reason is nothing but angle between tangent and the radius through its point of contact will be equal to 90 degree. In order to prove this PA is equal to PB, for the next case, let me join PO. So after joining PO, you can see that there are two triangles, triangle APO and triangle BPO. Listen here. Whenever I'm considering both of those two triangles, I can see that length of AO and BO are equal because both are radii. And one more thing I can write, PO, length of PO will be equal to PO because that side is a common side to both of the triangles. Again, I got angle A equal to 90 degree, angle B is equal to 90 degree. In the bracket, while you're writing the same concept in exam, you have to write like this, angle between tangent and radius through its point of contact is equal to 90 degree. That reason you must write here. Okay, now I'm not writing, but for exam you have to write it. Now you can see that triangle APO, according to grade 9, the congruency of triangle concept, I can write triangle APO and triangle BPO are congruent. As those two triangles are congruent, obviously I can write that according to CPCT, the third side PA of the first triangle will be equal to third side of the second triangle PB. The reason is nothing but a CPCT. So try to understand the concept. So tangents from an external point. So from the external point of a circle, we can draw two tangents. Those two having same length, PA will be equal to PB. I gave you the proof by using the concept of congruency of triangles. So this question is very important in exam point of view. So we are going to try, or we are going to do the first question. You can see from a point Q, the length of tangent to a circle is 24 centimeters. So I'm constructing a figure based on the given question. I'm having a circle. From the point Q, the length of the tangent to a circle. So there is a point Q, an external point Q is there. From that external point Q, there is a tangent towards a circle. Let me, its point of contact is A. So this length of the tangent is given as 24 centimeter. And the distance of Q from the center is 25. So here is the center of the circle O. According to the question, distance between this Q and this O is equal to 25 centimeter. They are asking to evaluate the radius to find the radius. So AOB will be R. AO is R, radius. Okay. Now listen properly. We know that QA is a tangent. OA is a radius through point of contact. I can write this will be equal to 90 degree as we know. So which means triangle AQO now it's a right angled triangle. According to right angled triangle, we can apply Pythagoras theorem. Pythagoras theorem says that hypotenuse square, which is 25 square, is equal to base square 24 square plus altitude square. Instead of altitude it is r square, so 25 square is equal to 24 square plus r square is getting. I think it's clear for you. So hypotenuse is 25, which is the side opposite to 90 degree. Base is 24 and altitude is r squared. So we can write 25 square is 625. 24 square is 576 plus r squared. From here we are getting r square is equal to 625 minus 576, which is equal to 49. So radius of the circle is equal to 7 centimeter. You can expect this question for 1 mark. So we use the concept nothing but the angle between tangent and the radius of its point of contact will be equal to 90 degree, and we identified that one as a right angled triangle. We applied Pythagoras theorem. I got the answer. The radius of this circle as equal to 7 centimeter. Now we are doing second question. In second question, we can see there is a circle. TP and TQ are two tangents. The central angle POQ is given as 110 degree as per the figure. We need to find angle PTQ. Okay, so listen here. We know that angle P will be equal to 90 degree because PO and PT are perpendicular according to our concept. So I can write angle P equal to 90 degree. Similarly, angle Q is also equal to 90 degree. So angle Q is equal to 90 degree. So we can see that OPTQ, it is a quadrilateral. In a quadrilateral, angle sum is equal to 360 degree. You can add 4 of the angles. What is that? 110 is the first angle plus second angle is 90, third angle is 90, fourth angle is PTQ. You know that if you're adding 4 angles of a quadrilateral, we are expecting to get 360 degree. 90 plus 90 is 180 plus 110, it is 290. So I'm getting 290 plus angle PTQ is equal to 360 degree. From there I can write angle PTQ is equal to 70 degrees. So angle PTQ is equal to 70 degree. This question also you can expect for 1 mark. Now we are doing third question. What is the third question? Prove that the tangents drawn at the ends of a diameter of a circle are parallel. It's very important. All of you listen here. We having a circle and we are constructing one of its diameter. According to the question, through the endpoints of the diameter. So you can see that this is the first endpoint of the diameter. This is a second endpoint of the diameter. Through the endpoints of the diameter, we are constructing tangents. That is given in the question. Question says that we need to prove that those two tangents are parallel. Let me write this one as tangent 1, T1, and this one as tangent 2, T2. We need to prove that T1 will be parallel to T2, where T1 is the tangent passing to the one of the endpoint of the diameter. T2 is also another tangent passing through the endpoint of the diameter. Is it clear? Now let me mark this point of contact as A and the center as O and this as B. We know that AB is the diameter. Obviously, it will pass through the center of the circle, which is denoted by O in the figure. Okay. Now listen. According to the concept that we have discussed already, I can write angle between tangent and this radius AO will be equal to 90 degree. Similarly, angle between this tangent and radius OB is also equal to 90 degree. You can see that alternate angles are equal. In grade 9th, from the chapter of lines and angles, you have learned that if two lines are parallel, let me plot that one in a rough manner. If two lines are parallel, if you're cutting that one by a transversal, then its alternate angles are equal. That you have learned in grade 9th. Here, I got the alternate angles as equal, which implies both of those lines must be parallel. In grade 9, we have learned like this: if two lines are parallel, alternate angles are equal. What is the converse of that one? If alternate angles are equal, then lines are parallel. Here, alternate angles are already equal. That's why I can write T1, tangent 1 is parallel to T2. Here you can mention the reason. Alternate angles are 90 degree. Before that one, you can write here like, let me write P here, and here I write Q. So before that one, you can write what? Angle PAB is equal to 90 degree. Angle QBA is also equal to 90 degree. You have to mention the reason. It is nothing but angle between tangent and the radius through its point of contact will be equal to 90 degree. As the alternate angles are 90 degrees, which means they are equal, I can write that T1, the line T1 is parallel to line T2. So that's the concept of third question. Okay. So now we are moving to question number 4. All of you listen here. We are doing fourth question. What is the fourth question? Fourth question says that we are having a figure. From the figure, it is clearly given that a quadrilateral ABCD is there. It is circumscribing the circle, isn't it? So we need to prove that AB plus CD is equal to AD plus BC. It is very important in exam point of view. All of you listen here. If you consider this figure, you can see that there are 4 external points to the circle. Point A is an external point, B is another external point, C is another external point, and D is also another external point. From the external point A, I can draw 2 tangents, which are the AP and AS. So according to the concept, we know that AP and AS will be equal because they are the tangents drawn from the external point A. So let me denote length of AP and AS as A. Both are equal. So I can write the reason is nothing but both of them are equal tangents. Similarly, B is another external point. So tangents drawn from B are BP and BQ. They are also in equal length. So BP equal to BQ is equal to, let me mark it as B. The same reason, equal tangents. C is another external point. From C, there are 2 tangents, CQ and CR. Both is having same length, denoted by the letter C. So QR is Q is equal to CR is equal to C. Same reason of equal tangents. Finally, D is another external point. So from D, DR and DS are 2 tangents. Both is having same length of D. Equal tangent concept is stated. So this points I can easily write according to the concept of equal tangents. Now you come to the question. Question says LHS as AB plus CD. You can see that length of AB is AP plus PB, which is equal to A plus B plus CD means CR plus RD from the figure, which is equal to C plus D. So I'm getting AB plus CD equal to A plus B plus C plus D, which is my LHS. Now I'm checking what is the value of RHS. RHS is given as AD plus BC. What is AD? AD means from the figure it is AS plus SD, which is equal to A plus D. Then BC is there, which is BQ plus QC, that is equal to B plus C. Now you can see that what is the value of LHS, that is A plus B plus C plus D. What is the value of RHS, that is also A plus B plus C plus D, which means both LHS and RHS are equal. So I can write AB plus CD will be equal to AD plus BC. So it is a board level question, so try to understand the concept. We have used the concept of equal tangents. There are four external points. Pair of tangents drawn from those four external points are equal in length, like AP equal to AS is equal to A, BP is equal to BQ is equal to B, CQ is equal to CR is equal to C, DR is equal to DS is equal to D. Now we applied AB plus CD, we got that one as A plus B plus C plus D, and also AD plus BC we got like A plus B plus B plus C. Both of them LHS and RHS are equal, so I can write that as the proof AB plus CD is equal to AD plus BC. I repeat, it is an important board level question.